Hey you guys, we are going to just do one problem today. I promise that's it, one problem. Shouldn't be more than 10 minutes, but I really want you guys to try to follow me and understand what's going on and how I'm getting every step, because then it'll make tomorrow a lot easier. We're going to spend a lot of time tomorrow going over the quiz because you'll see today, like even in this problem, it's all carrying through. So like the inverse cosine stuff, adding that 360n, adding that 2 pi n, it's all going to come back. So, all right, what we're going to do right here for this problem is the directions are to find the first three values when y equals 5. First step is going to be to get theta in terms of y. So let's go ahead and start kind of stripping all of this stuff away to get theta by itself. First step obviously is going to be to subtract the 4. And then you're going to have that division by 3. So let's subtract the 4. Now, dividing by 3 is the same thing as multiplying by 1/3. So you can just do that. All right, and then you're left with this beauty over here. Okay, now we need to get rid of this cosine. So we can't divide out just cosine. So what we need to do is multiply it by the inverse cosine. So bye-bye, bye-bye. And group all of that together. Your grouping is going to be really, really important in this section. All right, from here we have the 2 that's being multiplied. So to undo that, let's divide it out, which obviously is the same thing as multiplying by 1/2. Okay, I'm going to clean this up a little bit so it looks a little bit better. Okay, obviously to get theta by itself, you need to subtract off your 20 degrees. So once you do that, you put a negative 20 degrees out in front. You are good to go. Okay, so now we have everything in terms of theta. So we need to find our first three values when y equals 5. So you're going to go ahead and substitute in your 5 into the y. So 5 minus 4, it's going to be a 1. 1 times 1/3 is 1/3. So you're left with negative 20 degrees plus 1/2 inverse cosine of 1/3 equals theta. So you can't do that one in your head, so you need to go and grab your calculator, make sure you're in radian mode, and let's take the inverse cosine of 1/3. And I lied, you should be in degree mode, not radian mode. Okay, so inverse cosine of 1/3. Let's say 70.529. Okay, so I'm going to come off to the side here and write that down. So in terms of degrees, okay, think back to inverse cosine, you guys. What do we know? It has to be, okay, it's going to be a positive, it's going to give us a positive value. So we know cosine is positive in the first and fourth quadrants. Okay, so get rid of that. So we know we're going to have a value here. We're going to have a value here. Obviously, this one is going to be our 70.529 degrees. This one down here is just going to be our negative 70.529 degrees. So in order to represent that, we need to have both of these values, but also don't forget plus 360 degrees n. We need to have that for both. And obviously, you could write this as plus or minus, which we're about to do. So let's come back over here to our problem. You have negative 20 degrees plus 1/2. Now, instead of writing this inverse cosine stuff, I'm going to get rid of the highlighter. What we're going to do instead is put our plus or minus 70.529 degrees plus 360 degrees n equals theta. Okay, so from here we need to distribute in this 1/2. So we have negative 20 degrees plus, okay, half of 70.529 is going to give us plus or minus 35.2645 degrees plus half of 360 is 180n equals theta. Here's where it starts to get a little ugly, and it's just in how you organize your paper, so just be really, really careful. Okay, I'm going to have my two separate cases, one with a plus, one with a minus. So my first case I'll do in purple, negative 20 degrees plus 35.2645 degrees plus 180n. So that's one value. And then my second value I'll do in red. I have negative 20 degrees minus 35.2645 plus 180 n. Okay, so from here it's pretty much just calculator. So if you put, do those two values together, you're going to get 15.2645 plus 180 degrees n. If you come over here, you're going to get negative 55.2645 degrees plus 180 n. Okay, so we want the first three positive values. So the next step from here is just to figure out, okay, what if n is 0? Okay, what if it's 1 and 2? And that's basically going to catch all of the rotations. You will not have to go really any further than that with the two combined values. So if n is 0, if n is 1, if n is 2, again, this is just the rotations. So if n is 0, we don't even have to add this 180n, so we just get 15.2645 degrees. Okay, if n is 1, again, this is all just calculator, plug it in. You can go ahead and get, okay, so this one, I mean, isn't too bad. You can do it in your head, but I just want to make sure I show you guys the steps. So that's going to be your 195.2645 degrees. And then if n is 2, you can either, start from the beginning and add 360, or you could just add 180 onto the value you already have. And you get 375.2645 degrees. Okay, so we can't figure out our answers yet because we need to come over here and figure out when n is 0, n is 1, and n is 2. So when n is 0, that's the easiest one, right? So now when n is 1, let me scooch this over here, our negative 55.2645 plus 180, 124. Then go ahead and add another one onto that. You can pretty much tell, though, you're probably done. 304 point. And obviously that's way above the others. And we're looking for the first three positive values. Kind of important to know, sorry. The first three positive values when y is 5. So let's go through and check it out. Our first one is going to be, oh boy, 15.2645 degrees. Check. All right, our second one over here is 124.7355 degrees. And our third one, come back over here, 195.2645 degrees. And that is it. In order to check it on the calculator, of course, you could check it with my answers, but to be a little bit more independent, all you're going to do is put your original in. So put this one in right here. Make sure you're in degree mode, which you should be in degree mode because you already figured out the inverse cosine, so that shouldn't change. All right, so go to your window. If a lot of you guys I think already have good windows set up for trig. But in this case, I did my x min. I'm looking for only the positive value, so I don't care about going too far negative. So I have negative 90 to 360. Going by ones doesn't matter. My y min is negative 2. My y max is 10 because I know I'm going to be plugging in a value of 5 for y. So I want it to go at least up to 5. So I went a little bit more to 10. Your y scale can go by 1. That's fine. So you enter in, like I said, the original equation. Do not put in the one that you simplified. And then go ahead and graph it. So there's mine. Now, the one thing that we need to include, though, is we want to find the intersection. We're asking you to find the first three positive values when y is 5. So I'm going to put a 5 in there. Go ahead, graph it again. It's going to cut through. And then from here, you can just use the intersection feature. So second calc, 5 for intersect. I can, it looks like it wants to do this one right here. So you can do it whatever order you want. All right, so there's one first intersection, 124.735, blah, blah, blah. Hey, there it is, okay? Let's try another one. So second, calc, intersect. I'm going to scooch, well, let's do the third one. Let's see if we were right. Okay, second curve, guess. As long as you're close to the curve, it'll do that one. Okay, 195, woohoo! And then if you want to go crazy, you can go ahead and check that first one. I'm not going to. And that's it, all right? So this is pretty much what we're going to be doing tomorrow. Problems just like this. It's an intro, but I think you guys should be okay. So I will see you then. Bye-bye.